Hi. Welcome to the lot sizes topic in SAP IBP explainer video series from GitaCloud. This series is aimed at supply planners and any other IBP practitioners. This is part 6. It explains the production cycle lot size procedure, as well as lot size parameters. Production cycle lot size procedure is relevant for products that are produced with a set frequency, for example, produced every 7 weeks. Demand within the production cycle are covered by a single production event. We will focus on the subassembly IBP 101S, which is needed to produce the finished good IBP 100 in response to demand from EMEA region customers. Plant 1010 replenishes Distribution Center 3710, which ships product to customers in the EMEA region. We set the subassembly IBP 101S in Plant 1010 with lot sizing procedure 3, production cycle lot size. We specify the production cycle as 7 weeks in the production source of supply master data type. Note that the production lead time attribute must be set to blank for this procedure to work. Consensus demand for 10 units in week 36 propagates to DC 3710 in week 34 given 2 weeks customer transportation lead time. The dependent demand for IBP 100 at DC further propagates to plant 1010 in week 33. This dependent demand further propagates down the bill of material to the subassembly IBP 101S in week 32 given 1 week assembly lead time for the finished good. Now that we understand the demand propagation from FG-customer level demand to plant, subassembly level demand, let's focus on the production cycle lot size procedure. Note the key figure, first production subperiod. It needs to be populated once to indicate the start of the production cycle. We indicated the production cycle to start in week 31. Given the 7-week production cycle, IBP automatically plans for the next production cycle to occur in week 38, then in week 45, and so on. IBP combines all the dependent demand within the production cycle horizon of 7 weeks. For example, IBP plans 700 units of net demand in week 38 to cover for dependent demands from week 38 till week 44, which add up to 700 units. Projected stock key figures show the inventory pre-build due to the production cycle. Lot sizing procedures are defined in location product master data type and determine how to bundle demand across periods. Lot size parameters are defined in customer, location, or production source of supply level, and dictate the range within which the planning algorithm can choose a lot size. No lot size parameters are supported for external source of supply. We recommend modeling suppliers as locations, if you need to model minimum lot size or rounding value constraints from suppliers. Minimum lot sizes generally make sense to model to cover contractual obligations or to meet commercial viability thresholds. IBP inflates receipts to get to this minimum lot size, whether for transportation or production purposes. IBP can only do this if enough capacity and raw materials exist to support this inflation of demand in case of supply optimizer or finite supply heuristics. Maximum lot size limits production or transportation to a threshold. Infinite supply heuristics does not respect maximum lot size, as it needs to fulfill demands in full, irrespective of the demand being greater than the maximum lot size. However, supply optimizer as well as finite supply heuristics respect maximum lot size. Rounding value can be modeled to cover use cases such as a packaging constraint, to produce or transport in certain increments. Let's evaluate the planning results from infinite supply heuristic with rounding value set to 40. You can see that demand within the first production cycle, week 31 to week 37, is 210 units, but receipts are planned for 240 to respect the rounding value. This gives us 30 units in surplus stock at the end of week 37. Demand within the second production cycle, week 38 to week 44, is 700 units. We have 30 units of projected stock in week 37 because of rounding value related surplus stock in the previous cycle. So, we have to plan for 700 minus 30, which equals 670 units of demand. This now gets rounded up to 680 units due to rounding value constraint, as you can see in the receipts key figure in week 38. Let's evaluate the planning results from infinite supply heuristic with minimum production lot size set to 250, along with rounding value set to 40. You can see that demand within the first cycle, week 31 to week 37, is 210 units, but we need a minimum lot size of 250. Given the rounding value of 40, the receipts are further adjusted up to 280. Receipts of 280 versus demand of 210 leaves us with surplus stock of 70 units, which can be seen in week 37 in the projected stock key figure. Total demand for the second production cycle is 700 units, week 38 to 44. This leaves us with 700 minus 70, which equals 630 units of demand. This demand of 630 already meets the minimum requirement of 250, hence it is simply adjusted up to 640 per the rounding value parameter. Infinite supply heuristic ignores maximum production lot size parameter. You can see that we continue to have 640 units planned in week 38, which is in violation of the maximum lot size constraint of 600. The results are exactly the same when we had a blank value in the maximum lot size attribute. Let's see how Supply Optimizer runs differently with maximum production lot size. You can see that Optimizer planned only 560 units in week 38, to respect the maximum lot size constraint of 600. Note that Optimizer propagates the dependent demand from DC to plant differently per other cost drivers. Refer to the table here to understand which lot size parameter is respected by which planning algorithm. We just saw how infinite supply heuristic ignores the maximum lot size parameter, although the Supply Optimizer respects it. Note that customer source of supply does not have any minimum and maximum lot size parameters, only the rounding value, which is respected by both the infinite supply heuristic and Supply Optimizer. We modeled a rounding value of 25 in lot size rounding value and customer source of supply master data type. Now, infinite supply heuristic rounds up consensus demand in every period to a multiple of 25. This has the effect of inflating the customer receipts to 1,360 compared to consensus demand of 1,200 across all the periods. Given supply heuristic cannot plan on the customer to store any excess shipped, it continues to plan higher quantities across all periods. Concept of carrying over surplus stock at customer does not apply. In conclusion, production cycle lot size is supported in IBP for products on a production cycle. This helps to cover the entire demand within the production cycle by a single production event. Lot size parameters can be applied to further influence the production or transportation lot quantity. See other videos in this lot size series to understand all the lot sizing procedures in detail. You can find this and all other IBP Explainer series videos at GitaCloud website or GitaCloud YouTube channel. SAP IBP has a wide range of demand or supply planning features that your planners may be interested in. GitaCloud can help you understand how IBP can model your specific planning problems and how that adds value to your planners. You can reach us with a quick email to connect@GitaCloud.com. Hope you enjoyed this video. Please like and share if you did. Have a great week.